5, 4, 3, 2,
Yede Prajalua
1, 0.
Hi students, welcome to GM Alama Anubandha Student Support Program. In the previous video clip, so we discussed about the refractive index of material of the prism and also its angle of minimum deviation. Now today class, let us see some of the competitive examination applications based on this prism or that angle of minimum deviation. Okay, so before going to discuss about that, the first, here we have that thin prism. What is this thin prism? The name itself, it says that thin prism. Thin means what? In the sense of size. Size is also a small in size. So when the size of the prism is small means, then what is the angle of incidence of that angle of that prism? Angle of the prism. Okay. So thin prism means the prism is a very small and the angle of prism, that is angle of prism A is lesser than 10 degree. Okay, so ಎಷ್ಟು ಸ್ಮಾಲ್ ಇರುತ್ತಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ ದ ಆಂಗಲ್ ಆಫ್ ಪ್ರಿಸಮ್ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ 10 ಡಿಗ್ರಿ. ಸೊ ಆ ಥರ ಪ್ರಿಸಮ್ಗೆ ನಾವೇನಂತ ಕರಿತೀವಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ ಥಿನ್ ಪ್ರಿಸಮ್ ಅಂತ ಕರೆಯುವಂಥದ್ದು. ಓಕೆ, ಸೊ ನಾವು ಲೆಟ್ ಅಸ್ ಸಿ ದ ಮಿನಿಮಮ್ ಡಿವಿಯೇಷನ್ ಇನ್ ದ ಕೇಸ್ ಆಫ್ ದಿಸ್ ಥಿನ್ ಪ್ರಿಸಮ್ ಟು ಫೈಂಡ್ deviation. Okay, so to find deviation in this thin prism, how to find deviation, or this thin prism deviation dependent on which factors? So now here in the case of prism we derived the formula, the refractive index of material of the prism, that is equals to mu is equals to sine of A plus dm. So divided by 2, it's whole divided by sine of A by 2. So previous video clip alli ಈ ಫಾರ್ಮುಲಾ ನಾವು ಡೆರೈವ್ ಮಾಡಿದ್ದೀವಿ ಆಲ್ರೆಡಿ. ಸೊ ನಾವು ಫಾರ್ thin prism here, so sin I, we are going to take sin I is approximately equals to I, that is sin theta is approximately equals to theta, like that. Sin R is approximately equals to R, that is, so that what happens here, it reduces, this equation reduces to mu is equals to sin theta is approximately equals to theta, that is sin I is approximately equals to I, means we have only that I value, incident value, that is A plus dm by 2 whole divided by, so remaining, that is, okay, sin R is approximately equals to R, means, so we have this expression, that is A divided by 2. So now in this 2 to get cancelled, so remaining we have, so refractive index mu of A plus dm divided by the angle of the prism, that is A. So if you cross multiply this equation, that is mu A, right hand side we have A plus that minimum deviation dm. So angle of the prism, if you brought this A to the left hand side, means, so which is equals to minimum deviation dm here. So what is the common means? Angle of the prism, so mu minus 1, that is equals to minimum deviation. So this is the deviation produced by thin prism. Here that thin prism deviation depends on, one it is angle of the prism, second one is a refractive index of that thin prism. Okay, so ಇವೆರಡು ಫ್ಯಾಕ್ಟರ್ ಮೇಲೆ ಸೊ thin prism deviation ಏನಾಗಿರುತ್ತೆ, ಸೊ ಡಿಪೆಂಡೆಂಟ್ ಆಗಿರುವಂಥದ್ದು. ಓಕೆ, ಸೊ ಒನ್ಸ್ ಅಗೇನ್ ಐ ವಿಲ್ ಕನ್ಕ್ಲೂಡ್ ದಿಸ್ thin prism ಕಾನ್ಸೆಪ್ಟ್, ಪ್ಲೀಸ್ ಲಿಸನ್ ಕೇರ್ಫುಲಿ. ಸೊ ನಿಮ್ಮ PUC ಎಕ್ಸಾಮಿನೇಷನ್ಗೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ ವಾಟ್ ಈಸ್ thin prism ಅಂತ ಕೇಳೋ ಚಾನ್ಸ್ ಇರುತ್ತೆ. ಸೊ ವಾಟ್ ಈಸ್ thin prism ಅಂತ ಹೇಳಿದ್ರೆ, ಇಫ್ ದ ಆಂಗಲ್ ಆಫ್ prism is less than 10 degree, or if prism is a small prism, that is angle is lesser than 10 degree, such a kind ಅಥವಾ ಆ ಥರ ಒಂದು ಪ್ರಿಸಮ್ಗೆ ನಾವೇನಂತ ಕರಿತೀವಿ, thin prism ಅಂತ ಕರಿತೀವಿ. ಸೊ ಅದರಲ್ಲಿ ನಾವು ಡಿವಿಯೇಷನ್ನ ಪಾಯಿಂಟ್ ಔಟ್ ಮಾಡಬೇಕಪ್ಪ ಅಂದರೆ ತಿನ್ ಪ್ರಿಸಮಲ್ಲಿ. ಸೊ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ ದಟ್ ಸೊ ಫಾರ್ಮುಲಾ. ಸೊ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಆಫ್ ದಿ ಪ್ರಿಸಮ್ ಇನ್ ದ ಕೇಸ್ ಆಫ್ ಆಂಗಲ್ ಆಫ್ minimum deviation, that is mu is equals to sin of a plus dm divided by 2 of sin a by 2. Here this sin I is approximately equals to I means, so that what happens here, sin r also approximately equals to r. This equation reduces to this format. If we take angle of the prism as a common means, we have a of mu minus 1 which is equals to minimum deviation. This formula tells that angle of minimum deviation of a thin prism dependent on so refractive index of the prism and angle of the prism. Okay, so now let us move to the next concept. So what is the next concept means? Our competitive examination applications, that is first one, it is normal incidence grazing emergence. The first condition, it is normal incidence grazing emergence. What are the condition for normal incidence and grazing emergence? Now let us see that. The normal incidence means, if we consider a prism here. So now in this prism here, A is the angle of the prism A. The light ray is incident normally. Okay, so light ray ಏನಾಗುತ್ತೆ ಈಗ ನಾರ್ಮಲ್ ಆಗಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗುತ್ತೆ. ನಾರ್ಮಲ್ ಇನ್ಸಿಡೆನ್ಸ್ ಮೀನ್ಸ್, ಸೊ ದ ಲೈಟ್ ರೇ ಇನ್ಸಿಡೆಂಟ್ ನಾರ್ಮಲಿ ಲೈಕ್ ದಿಸ್ ಈಸ್ ದ ಇನ್ಸಿಡೆಂಟ್ light ray. When the light ray incident normally means at the first surface, okay, at the first surface, what is the angle of incidence? Okay, so point number 1 here I am writing I1 is equals to 0. Similarly, R1 is equals to 0. Why? Because at the normal, that means for the normal incidence, angle of incidence and angle of refraction is equals to 0. Where? At the first surface. If you come to the second refracting surface, at this point here, if you draw a normal to know the angle of incidence. Okay, so when the light ray incident normally means here, so the angle it is, what is the angle we are going to say that? So when the angle of incidence is equals to a critical angle, then what is the refracted angle? Refracted angle is 90 degree. So when the angle of incidence is greater than critical angle, so that what happens? TIR phenomena will takes place. Here when the light ray incident normally on the second refracting surface means, this light ray so emerged, ಈ light ray ಏನಾಗುತ್ತಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ it grazing emergence. ಸೊ here ನಾರ್ಮಲ್ ಇನ್ಸಿಡೆನ್ಸ್ ಗ್ರೇಸಿಂಗ್ ಎಮರ್ಜೆನ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ, ಇಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗಿರೋಂಥ ಸೆಕೆಂಡ್ ಸರ್ಫೇಸಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗಿರೋಂತಹ ಲೈಟ್ ರೇ ಏನಾಗುತ್ತೆ, ಸೊ ಇಟ್ ಗ್ರೇಜಸ್ ದಟ್ ರಿಫ್ರಾಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್. ಆ ಪ್ರಿಸಮ್ನ ರಿಫ್ರಾಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್ ಏನು ಮಾಡುತ್ತೆ, ಅದು ಗ್ರೇಸ್ ಮಾಡುತ್ತೆ. ಸೊ ನಾವು ಇನ್ ದಿಸ್ ಸಿಚುವೇಶನ್, okay, so what is the angle of emergence means, that is I2 is equals to 90 degree. Here what is that angle of incidence? So what is the R2 value here? So what is the R2 means? R2 is equals to angle of emergence 90 degree ಇದೆಯಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ, for which corresponding angle is theta c, that is equals to critical angle. R2 is equals to theta c. So now here we can able to write that I2 is equals to 90 degree and R2 is equals to a critical angle, that is theta c. This is the first condition. Second one here, to calculate the angle of the prism, A is equals to R1 plus R2. So here what is the angle of the prism means, A is equals to R1 value is 0 plus R2 is equals to critical angle theta c. So that now we can able to write angle of the prism is equals to critical angle, that is theta c. And we know that this critical angle theta c is equals to, okay, or sin theta c, critical angle condition sin theta c is equals to 1 divided by mu. This relationship already be obtained in the case of total internal reflection, where the relation between refractive index and critical angle, that is sin theta c is equals to 1 by mu, or theta c can be written as sin inverse of 1 divided by mu. Okay, so your theta c, this theta c can be written as sin inverse of 1 divided by mu. And the next point, to find the deviation. So the deviation formula we have, dou is equals to I1 plus I2 minus angle of the prism A. Here deviation I1 is 0, I2 is 90 degree minus angle of the prism, what is that is theta c, or deviation is 90 minus theta c, 90 degree minus theta c. Okay, or this can be written as deviation produced 90 minus theta c andre ಏನು angle of the prism A. Okay, so these are all the conditions we have for normal incidence and grazing emergence. Okay, when the light ray incident normally, okay, so first refracting surface angle of incidence is equals to 0, angle of refraction is also equals to 0. At the second refracting surface it grazes that surface, ಏನಾಗುತ್ತೆ ಈ ಸರ್ಫೇಸ್ ಮೇಲೆ ಏನಾಗುತ್ತೆ ಗ್ರೇಜಿಂಗ್ ಮಾಡುತ್ತೆ, ಅಂದರೆ ಅದ್ರ ಮೇಲ್ಮೈಯಲ್ಲೇ ಬರುವಂಥದ್ದು. ಸೊ ಅಟ್ ದ ಟೈಮ್ ದ ಆಂಗಲ್ ಆಫ್ ಎಮರ್ಜೆನ್ಸಿ is 90 degree. When the angle of emergence is 90 degree means the corresponding angle is critical angle, that is R2 is equals to theta c. So that we have for that conditions. Okay, this is the deviation and this is the angle of prism, that is equals to critical angle, and these are all the values we are going to observe in this case. This is the possible when the normal incidence and grazing emergence ಅಂತ ಹೇಳಿದ್ರೆ ಈ ಕಂಡೀಷನ್ಸ್ ಇರುವಂಥದ್ದು. Now let us move the next concept here. Normal incidence, grazing emergence ಆಯಿತು. ಈಗ grazing incidence, okay, so grazing incidence and grazing emergence. ಸೊ ಫಸ್ಟ್ ಏನಾಗಿತ್ತು ಈ ಕಂಡೀಷನಲ್ಲಿ, ಲೈಟ್ ರೇ ನಾರ್ಮಲ್ ಆಗಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗಿತ್ತು, ಗ್ರೇಜಿಂಗ್ ಆ್ಯಂಗಲ್, ಗ್ರೇಜಿಂಗ್ ಎಮರ್ಜೆಂಟ್ ಆ್ಯಂಗಲ್ ಏನಾಗಿತ್ತು, ಗ್ರೇಜಸ್ ಆಯಿತು, ಪ್ರಿಸಮ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಗ್ರೇಜಸ್ ಆಯಿತು. ಸೊ ನಾವು ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಅಬ್ಸರ್ವ್ ಗ್ರೇಜಿಂಗ್ ಇನ್ಸಿಡೆನ್ಸ್, so that we have grazing emergence. For that, if we consider here, this is the prism, light ray should, okay, so what is the angle of incidence, that should be grazes the surface. Light ray ಏನಾಗಿರಬೇಕು, ಈ ಸರ್ಫೇಸ್ ಅನ್ನ ಗ್ರೇಜ್. ಫಸ್ಟ್ ರಿಫ್ರಾಕ್ಟಿಂಗ್ ಇನ್ಸಿಡೆಂಟ್ ಲೈಟ್ ಏನು ಮಾಡಬೇಕು, ಸೊ ಹಿಯರ್ ಇಟ್ ಗ್ರೇಜಸ್ ದ ಸರ್ಫೇಸ್, ದ ಇನ್ಸಿಡೆಂಟ್ ಲೈಟ್ ರೇ grazes the surface. At certain stage it's get refracted. Once again while emerging, here there is a change in medium, light ray emerges to outside. Okay, that emerged light ray, what happens, it also grazes. Okay, so here, so that emerged light ray also grazing the surface. Okay, so for grazing incidence and grazing emergence, what are the condition we need to observe? Okay, light ray, so grazing angle ಅಥವಾ ಈ ಸರ್ಫೇಸ್ ಅನ್ನು ಗ್ರೇಜಿಂಗ್ ಮುಖಾಂತರ ಇನ್ಸಿಡೆಂಟ್ ಆಗಿ ಅದಾದ ನಂತರ ರಿಫ್ರಾಕ್ಟ್ ಆಗಿ ಮತ್ತೆ ಗ್ರೇಜಿಂಗ್ ಅಥವಾ ಗ್ರೇಜಸ್ ಮುಖಾಂತರ ಏನಾಗುತ್ತೆ, ಎಮರ್ಜೆನ್ಸ್ ಆಗುವಂಥದ್ದು. ಸೊ ಈ ಕಂಡೀಷನಲ್ಲಿ, ಸೊ ಅಂದರೆ ಈ ಫಿನಾಮಿನಾ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್ ಆಗಬೇಕಾದ್ರೆ ವಾಟ್ ಆರ್ ಆಲ್ ದಿ ಕಂಡೀಷನ್ ವಿ ನೀಡ್ ಟು ಸಿ. ಓಕೆ, ಸೊ ದೀಸ್ ಆರ್ ಆಲ್ ದಿ ನಾರ್ಮಲ್ ಟು ನೋ ದ ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್. See, first refracting surface normal idu, second refracting surface normal idu. So now here the angle of incidence, what is the angle of incidence here? It is I1 is equals to 90 degree. When the angle of incidence, that means here angle of incidence is 90 degree means for which the corresponding angle ಏನಿರುತ್ತೆ, that is critical angle theta c. Once again look at here, the angle, the light ray is emerged. ಎಷ್ಟು angle emerge ಆಗಿದೆ, I2 is equals to how much, 90 degree. Okay, so ಇದಕ್ಕೆ corresponding angle ಏನಾಗಿರುತ್ತೆ, that is equals to theta c. So that now here the first condition, angle of incidence, that is I2 is equals to how much, 90 degree. So like that R1, R2 is equals to how much, theta c. critical angle theta c. R1 R2 is equals to theta c. So next here, to find the deviation angle of the prism, first A is equals to R1 plus R2. So now what is the angle of the prism? R1 plus R2 means R1 R2 is equals to theta c. It becomes now twice of critical angle. A is equals to 2 theta c. Next condition, if you want to find out the deviation, so deviation I1 plus I2, I1 plus I2 minus angle of the prism. This is the deviation formula. So here I1 value, I2 value how much? 90 degree we have. So deviation 90 degree plus 90 degree. Okay, so minus A means that is equals to twice of critical angle. So what is the deviation means? That is 180 degree minus 2 theta c. This is the formula we have. So that means that is the deviation produced. So when for the grazing incidence and grazing emergence, this is the deviation produced by the light ray. Okay, na? So this is the second application of your competitive examination for grazing incidence and grazing emergence. Yes, let us move to the next concept, that is maximum deviation produced by the light ray. Yes, my dear students, here the very simple it is grazing incidence, grazing emergence. ಅಂದರೆ ಲೈಟ್ ರೇ ಏನಾಗಿರಬೇಕು, ಈ ಸರ್ಫೇಸ್ ಗ್ರೇಜಿಂಗ್ ಮುಖಾಂತರ ಏನಾಗುತ್ತೆ ಲೈಟ್ ರೇ ಸ್ಟ್ರೈಕ್ ಆಗುವಂಥದ್ದು. ಓಕೆ, ಸೊ ಲೈಟ್ ರೇ ಸೊ ಯಾವ ಥರ ಸ್ಟ್ರೈಕ್ ಆಗುತ್ತಪ್ಪ ಅಂತ ಹೇಳಿದರೆ, so light ray incident, the incident ray falls on the prism with the grazing incident, so that it grazes from the okay, it emerges from the grazing surfaces. ಈ ಸರ್ಫೇಸ್ ಗ್ರೇಜಿಂಗ್ ಮುಖಾಂತರ ಏನಾಗುತ್ತೆ ಹೊರಗಡೆ ಬರುವಂಥದ್ದು. At the time here the angle of incidence is 90 degree means the for which the corresponding angle is theta c. You studied in that TIR. Like that here emerged angle 90 degree ಅಂದರೆ corresponding angle ಏನಾಗಿರುತ್ತೆ ಇಲ್ಲಿ theta c ಆಗಿರುವಂಥದ್ದು. So that angle of the prism becomes twice of the critical angle. Deviation becomes 180 degree minus twice of the critical angle. Now let us move to the next concept, that is maximum deviation produced in the case of prism. The next competitive examination application it is maximum deviation. Maximum deviation. To find the maximum deviation. Okay, so ಈ maximum deviation ನಾವು find out ಮಾಡಬೇಕಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ in the case of prism, so in order to obtain this condition, what is the condition for the maximum deviation means, let us consider a prism, principal section of this prism. Here to obtain the maximum deviation means, look at the deviation formula. What is the maximum deviation? Dou maximum is equals to, so what is the formula we have? I1 plus I2. I1 is the incident light ray, I2 is the emergent light ray. So minus I1 plus I2 minus that is angle of the prism A. ನಮಗೆ ಡಿವಿಯೇಷನ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬರಬೇಕಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಶುಡ್ ಬಿ ಹೌ ಮಚ್ 90 ಡಿಗ್ರಿ. ರಿಮೆಂಬರ್ ದಟ್ ಟು ಗೆಟ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಡಿವಿಯೇಷನ್. ಓಕೆ, ಸೊ ಐ ವ್ಯಾಲ್ಯೂ ಶುಡ್ ಬಿ 90 ಡಿಗ್ರಿ. ಓಕೆ, ಸೊ ಲೈಟ್ ರೇ ಏನಾಗಿರಬೇಕು, ಸೊ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆಂಟ್. ಓಕೆ, ಸೊ ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆಂಟ್ ಆಫ್ ಲೈಟ್ ರೇ ಶುಡ್ ಬಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇನ್ ಆರ್ಡರ್ ಟು ಗೆಟ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಡಿವಿಯೇಷನ್ ಅಂತ ಹೇಳಿದರೆ, ಸೊ ಲೈಟ್ ರೇ ಏನಾಗಿರ್ಬೇಕಪ್ಪ ಅಂತ ಹೇಳಿದರೆ ಇಟ್ ಶುಡ್ ಗ್ರೇಜಸ್ ದ ಲೈಟ್ ರೇ ಇನ್ಸಿಡೆಂಟ್ ಆಗಿರೋದು ಏನಾಗಿರಬೇಕು, ಸೊ ಗ್ರೇಜಿಂಗ್ ಆ್ಯಂಗಲ್ ಮುಖಾಂತರ ಲೈಟ್ ರೇ ಸೊ ಇನ್ಸಿಡೆಂಟ್ ಆಗಿರಬೇಕು. ಬಟ್ ಅಟ್ ಸರ್ಟನ್ ಸ್ಟೇಜ್ ಇಟ್ಸ್ ಗೆಟ್ ರಿಫ್ರಾಕ್ಟೆಡ್. ಓಕೆ, ಸೊ ದೇರ್ ಆಫ್ಟರ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಮೀನ್ಸ್ ಇಟ್ಸ್ ಎಮರ್ಜ್ಡ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್. ಓಕೆ, ಸೊ ಲೈಟ್ ರೇ ಗ್ರೇಜಿಂಗ್ ಆ್ಯಂಗಲ್ ಇನ್ ಇನ್ಸಿಡೆಂಟ್ ಆದರೆ ನಾವು ಹಿಯರ್ ವಾಟ್ ಈಸ್ ದ ಆ್ಯಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್? To get maximum deviation, angle of incidence should be 90 degree. So here angle of incidence ಎಷ್ಟಿದೆ 90 degree. I1 value is equals to 90 degree. Why? Because to get maximum deviation. So that now what happens here, this light ray refracted in this direction. Again it emerges to outside. ಈ direction ಅಲ್ಲಿ so emerged ಆಗಿದೆ. If you draw the normal at the second surface, so here we have for the 90 degree angle of incidence means here this angle becomes theta c. Here we don't know what is the angle of incidence at this point. Let us take it as R2. Okay, so light ray, if there is no medium means light ray would have traveled in this path, but because of change in medium, light ray deviated. So this what we call that dome maximum. But from the normal to this refracted light ray, this is the angle I2, that is equals to what? Emergent light ray. Now our intention is to calculate here maximum deviation. ಎಷ್ಟು maximum deviation ಎಷ್ಟಿದೆ, maximum ಎಷ್ಟಿದೆ. So that one we need to find out in this case. Now for the given diagram here, angle of incidence I1 is equals to how much? 90 degree, and R1 is equals to, that is critical angle, corresponding angle is theta c. Here we don't know what is the value of I2 and what is the value of R2. Now let us find first R2 value. The angle of the prism A is equals to R1 plus R2, angle of the prism. So R1 value is theta c. So now the angle of the prism theta c plus R2. Now this R2 can be rated as A minus theta c. Next, to calculate the angle of emergent light ray, or that is I2 means apply the Snell's law. Apply Snell's law where at second surface. Apply Snell's law at second refracting surface. Okay, so now by using the Snell's law here, look at here, at the second refracting surface the angle of incidence is R2, that is refractive index of prism multiplied by angle of incidence, that is R2, which is equals to light ray emerges to outside. Here what is the medium? Air medium, that is refractive index of air medium. Okay, so sine of angle, that is I2. For this the Snell's law at the second surface. Now the refractive index of prism, let us take mu p as mu, and refractive index of air medium, that is equals to 1, and also R2 value, what is the R2 value? We have A minus theta c, we calculated. So that now this equation reduces to refractive index of prism, that is mu sine R2. What is the sine R2 value? A minus theta c, which is equals to, okay, so refractive index of air medium is equals to 1, remaining we have sine I2. Our intention is to find I2 value. Why? Because we know that I1, that is normal, that is grazing angle, okay, angle of incidence grazes the surface, that is I1 is 90 degree to get maximum deviation. So now in this expression sine I2, so what is the value of sine I2 means? So that I2 can be rated as I2 na navenanta baribodu nodi, here it is, sine I2 can be rated as sine of I2 is equals to mu of sine A minus theta c, mu of sine A minus theta c. Next step, to calculate I2. Yeah, this one here I am going to write sine I2 is equals to mu of sine of A minus theta c. Here I2 angle can be rated as sine inverse of mu of sine of A minus theta c. This is the I2 value. Now to find the total deviation, now you substitute that value into the total deviation. A values anige ಮಾಡಿ total deviation ಅಲ್ಲಿ substitution ಮಾಡಿ. Okay, so now here this dome maximum, let us call this is the equation number 1. Okay, so here this is equation number 2, this is the equation number 3. Put 3 in 1. Okay, so when you put the equation number 3 in 1, so that maximum deviation, okay, so dome maximum is equals to, what is the dome maximum value? I1 value is 90 degree, okay, so that is for grazing incidence 90 degree plus I2 sine inverse of mu of sine A minus theta c, a minus theta c, sin inverse of mu of sine of a minus theta c minus of angle of the prism minus a minus of angle of the prism. Okay, so now look at that maximum deviation formula. So this is the formula we are going to use to calculate. Okay, so to calculate maximum deviation in the case of a prism. Yes, my dear students, once again listen to me. So now for maximum deviation, okay, maximum deviation me prism ಅಲ್ಲಿ ಬೇಕಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ, so the formula we have I1 plus I2 minus a deviation in the prism. So to get maximum deviation, angle of incidence should be a maximum, that is 90 degree. That means, so incident light ray grazed the surface, it refracted, so thereafter deviated. So this is what we call that maximum deviation. That one we need to find out. So for angle of incidence, that is I1 value 90 degree means for the corresponding angle is theta c. Here we don't know what is the R2, at which angle the light ray incident, and also we don't know what is that I2 value. So first you find out so R2 value, that is A can be rated as R1 plus R2, so that R2 can be rated as R1 is theta c andre R2 is equal to A minus of theta c. Next to find I2, that is at the second surface, you implement Snell's law. Refractive index of prism sin of R2 is equal to refractive index of air medium sin of I2. If R2 value is equal to A minus theta c, refractive index of prism take it as mu, and refractive index of air medium is equal to a 1, so that so this equation reduces to I2 is equal to sin inverse of mu of sin of A minus theta c. If you substitute this three equation number into equation number 1, so that I1 90 degree, I2 we calculated sin inverse of mu of sin of A minus theta c, A minus theta c again, so difference of angle of the prism, that is minus A equation we have. So now let us move to the next one more application, the last application, that is condition for no emergence. Condition for no emergence ಅಂತ ಹೇಳಿದ್ರೆ, ಈಗ ನಾವು ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ ಫಾರ್ಮುಲಾ ಫಾರ್ ದಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಡಿವಿಯೇಷನ್ಗೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಅಪ್ಲಿಕೇಶನ್ ಏನಪ್ಪ ಅಂದರೆ, ಲೈಟ್ ರೇ ಪ್ರಿಸಮಿಂದ ಎಮರ್ಜೆಂಟ್ ಆಗಬಾರ್ದು ಅಥವಾ ಹೊರಗಡೆ ಬರಬಾರ್ದಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ ವಾಟ್ ಇಸ್ ದ ಕಂಡೀಷನ್ ಇಟ್ ಶುಡ್ ಫಾಲೋ. ಕಂಡೀಷನ್ ಫಾರ್ ನೋ ಎಮರ್ಜೆನ್ಸ್. Condition for no emergence. So here once again let us consider a prism. So no emergence, light ray emergent ಆಗಬಾರ್ದಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ, so it should have traveled, that means the incident light ray should have traveled, that means the incident light ray should grazes the surface, the first surface. Before that you remember this point, if the angle of incidence is lesser than critical angle, what happens? Refraction of light phenomenon takes place. Light ray ಏನಾಗುತ್ತೆ? ರಿಫ್ರಾಕ್ಷನ್ ಆಗುತ್ತೆ. If critical angle is okay, so equals to that, the angle of incidence is equals to critical angle. Now what happens? So refracted ray ಏನಾಗಿರುತ್ತೆ? That is equals to 90 degree. When angle of incidence is greater than critical angle, now what is the condition? Light ray undergoes TIR phenomenon. That means light ray ಏನಾಗುತ್ತೆ? ಸೇಮ್ ಮೀಡಿಯಮ್ಗೆ ಕಮ್ ಬ್ಯಾಕ್ ಆಗುತ್ತೆ ನಮಗೆ. ಸೊ ನೋ ಎಮರ್ಜೆನ್ಸ್, ಪ್ರಿಸಮ್ ಇಂದ ಲೈಟ್ ರೇ ಎಮರ್ಜ್ ಆಗಬಾರ್ದು, ಹೊರಗಡೆ ಬರಬಾರ್ದು ಅಂತ ಹೇಳಿದ್ರೆ ಏನಾಗಬೇಕು? ಲೈಟ್ ರೇ ಸೇಮ್ ಮೀಡಿಯಮ್ಗೆ ಸೊ ಬರಬೇಕು. ಇಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗಿರೋ ಲೈಟ್ ರೇ, ಓಕೆ, ಫಾರ್ ದಿ ಲೈಟ್ ರೇ ಇನ್ಸಿಡೆಂಟ್ ಲೈಟ್ ರೇ grazes the surface, at certain stage it refracted, so thereafter what happens? It should come into the same medium. So before that light ray should follow the critical angle condition. For the critical angle condition means the angle of refracted ray, okay, should be equals to how much? The refracted ray angle should be equals to a 90 degree. So that means the angle of incidence grazes the refracting surface, draw a normal to know the angle of incidence, that is I1 is equals to 90 degree. So for which here the angle it is critical angle. Okay, so here this is theta c. And next at the second surface draw a normal. Okay, so here the angle of refraction emerged light ray agide 90 degree. At the time what is the condition? Here we have the corresponding angle is theta c. Light ray grazing angle in the incidence ಅಂತಪ್ಪ ಅಂದರೆ grazing angle ಇಂದ ಏನಾಗಿದೆ ಎಮರ್ಜೆನ್ಸ್ ಆಗಿದೆ. Okay, so now in this situation what are all the conditions means I1 I2 is equals to 90 degree, R1 R2 is equals to critical angle theta c. Now to find out the deviation, dou maximum. So what is the dou maximum? I1 I2 is 90 degree, 180 minus R1 plus R2 ಅಂತ ಹೇಳಿದ್ರೆ that is minus 2 theta c. But our intention is to calculate. So ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ನಾವು? ಲೈಟ್ ರೇ ಇಟ್ ಶುಡ್ ನಾಟ್ ಎಮರ್ಜಸ್. ಓಕೆ, ಇಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗಿರೋ ಲೈಟ್ ರೇ ಏನಾಗಬೇಕು? ಸೇಮ್ ಮೀಡಿಯಮ್ಗೆ ಕಮ್ ಬ್ಯಾಕ್ ಆಗಬೇಕು. ಓಕೆ, ಇಟ್ ಶುಡ್ ಒಬೇ ದ ಟಿ ಐ ಆರ್ ಫಿನಾಮಿನನ್ ಒಬೇ ಮಾಡಬೇಕಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ ಲೈಟ್ ರೇ. ಸೊ ವಾಟ್ ಇಸ್ ದ ಕ್ರಿಟಿಕಲ್ ಆಂಗಲ್? Angle of incidence should be greater than critical angle. That means here the angle of the prism can be rated as R1 plus R2. R1 R2 value is equals to what? Theta c, so that it becomes 2 theta c. Here if the angle of the prism, it's an important point, remember that the angle of the prism is lesser than 2 theta c, light ray ಏನಾಗುತ್ತೆ? Refraction ಆಗುವಂಥದ್ದು. So here it is refracted. That means it grazes the surfaces. If angle of the prism is greater than twice of the critical angle means the light ray undergo in the prism, the light ray undergo which phenomenon? TIR phenomenon. So that is the reason why in order to get the light ray ಇದರಿಂದ ಹೊರಗಡೆ ಎಮರ್ಜ್ ಆಗಬಾರ್ದು ಅಂತ ಹೇಳಿದ್ರೆ the angle of incidence, angle of the prism must be greater than twice times of the critical angle. This condition should be an important condition. If angle of the prism for no emergence, angle of the prism is greater than twice of the critical angle, so that now this can be rated as angle of the prism a by 2 is greater than critical angle. If I use sine angle on the both side, sine of a by 2 is greater than sine of theta c. So we know that relation sin theta c, critical angle. Okay, so relation between refractive index and critical angle ಅಂತ ಹೇಳಿದ್ರೆ sin of a by 2 can be rated as 1 divided by mu, or mu can be rated as 1 divided by sin of a by 2 angle. So 1 by sin theta can be rated as, 1 by sin theta is cosecant theta, so that refractive index is equals to mu of cosecant angle of a by 2. Light ray ಅಥವಾ ಪ್ರಿಸಮ್, ಓಕೆ, ದ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಆಫ್ ಪ್ರಿಸಮ್ ಶುಡ್ ಬಿ ಈಕ್ವಲ್ಸ್ ಟು ಕೊಸಿಕೆಂಟ್ ಆಫ್ a by 2 ಆರ್ ಆ್ಯಂಗಲ್ ಆಫ್ ದಿ ಪ್ರಿಸಮ್. ಈ ಕಂಡೀಷನನ್ನು ಒಬೇ ಮಾಡಿದರೆ ಲೈಟ್ ರೇ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗಿರೋಂಥ ಲೈಟ್ ರೇ ಸೇಮ್ ಮೀಡಿಯಮ್ಗೆ ಏನಾಗುತ್ತೆ, ಕಮ್ ಬ್ಯಾಕ್ ಆಗುತ್ತೆ, ಅಥವಾ ಇಟ್ ಅಂಡರ್ಗೋ TIR ಎಫೆಕ್ಟ್. ಸೊ ದಟ್ ಇಟ್ ಶುಡ್ ನಾಟ್, ಅಂದರೆ ಲೈಟ್ ರೇ ಇಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗಿರೋದು ಏನಾಗುತ್ತೆ, ಹೊರಗಡೆ ಯಾವುದೇ ಕಾರಣಕ್ಕೆ ಎಮರ್ಜೆಂಟ್ ಆಗೋದಿಲ್ಲ. ವಾಟ್ ದ ಕಂಡೀಷನ್ ಮೀನ್ಸ್ mu ಆಫ್ ಕೊಸಿಕೆಂಟ್ ಆಫ್ a by 2. Okay, it's enough, my dear students. Next I will continue.